students, KMS Elite Academy welcomes you all. Both online offline courses available. Kindly visit us www.kmseliteacademy.com. Today we are going to see class 12 chemistry, haloalkanes and haloarenes. What is haloalkane? Haloalkane is nothing but alkyl halide. In an aliphatic hydrocarbon, one of the hydrogen atoms is replaced by halogen atom is known as haloalkane. Haloalkane contain halogen atom attached to sp3 hybridized carbon atom of alkyl group. Here I have given two examples. One is chloroethane, another is 1,1 dichloroethane. Here halogen atom chlorine is attached to sp3 hybridized carbon. Here also two chlorine atom is attached to sp3 hybridized carbon. Next we'll go forward. Haloarene. Haloarene is also called aryl halide. In an aromatic hydrocarbon, one of the hydrogen atoms is replaced by halogen atom is known as haloarene. Haloarene contain halogen atom attached to sp2 hybridized carbon atom of aryl group. Here also I have given two examples. One is chloropensine, another is 1,2 dichloropensine. Here halogen atom chlorine is directly attached to sp2 hybridized carbon. Here also two halogen atoms attached to sp2 hybridized carbon. We know that benzene ring each contain sp2 hybridized carbon. Many halogen containing organic compounds occur naturally and find wide applications in clinical, industry as well as day-to-day life. Here I have given some of the halogen containing compounds and their uses in tabular column. Let us see the first compound, chlorine containing compounds is mainly used as antibiotic. Here I have given one of the antibiotic, chloroamphenicol. It is mainly used in the treatment of typhoid fever and eye infections. When we go for another compound, iodine containing compounds is mainly used in the treatment of goiter disease. We know that our body usually segregates thyroxine hormone, which deficiency causes goiter disease. Synthetic halogen compounds is mainly used in the treatment of malaria. Here I have given one of the drug named chloroquine. It is used in the treatment of malaria as well as prevention of COVID-19. Let us see the classification of haloalkanes and haloarenes. Haloalkanes and haloarenes may be classified in three ways. First one is that on the basis of number of halogen atom. Second one is that on the basis of compounds containing sp3 hybridized carbon X bond. Third one is that on the basis of compounds containing sp2 hybridized carbon X bond. Let us see the first classification on the basis of number of halogen atoms. In haloalkane, if only one halogen atom is attached to alkane, we can call monohaloalkane. If two halogen atoms is attached to alkane, we can call dihaloalkane. If three halogen atoms is attached to alkane, we can call trihaloalkane. It is similar way that in haloarene, if only one halogen atom is attached to arene, we can call monohaloarene. If two halogen atoms is attached to arene, we can call dihaloarene. Here also, three halogen atoms is attached to arene, we can call trihaloarene. Monohalo compounds may be further classified according to the hybridization of the carbon atom to which the halogen is bonded as discussed below. Let us see the second classification on the basis of compounds containing sp3 hybridized carbon X bond. It is further divided into three ways. One is alkyl halide, second one is allylic halide, third one is benzylic halide. When go for alkyl halide, it is nothing but haloalkanes. It is further classified as primary, secondary, tertiary halides. When go for allylic halides, the halogen atom is attached to sp3 hybridized carbon adjacent to sp2 hybridized. When go for benzylic halides, the halogen atom is attached to sp3 hybridized adjacent to sp2 hybridized carbon of arene group. When go for third classification, compounds containing sp2 hybridized carbon X bond. It is further divided into two ways. One is vinylic halides, second one is aryl halide. In vinylic halides, halogen atoms directly attached to sp2 hybridized carbon. In aryl halide also, halogen atom is attached to sp2 hybridized carbon of arene group. Aryl halide is also known as haloarenes. Let us see the nomenclature of haloalkanes and haloarenes. Here I have given some of the structure, common name, IPC name in table column. When go for the first structure, CH3CH2Br is common name as ethyl bromide. In IPC name, bromoethane. When go for second structure, we have to give the numbering from right to left, because halogen atom, where it is placed, that carbon will be the first carbon here. So here common name will be N-propyl bromide, whereas IPS name will be 1-bromopropane. When we go for third structure, here halogen atom chlorine is attached into second carbon. So we can call it 2-chloroputane in IPS name, and go for common name secondary butyl chloride. When we go for fourth structure, we have CH3CH, CH3, CH2Pr. So here common name will be isobutyl bromide. Why we are calling it iso? Because we have in the second carbon there is a branch methyl group. So we can call it iso. Butyl, we have totally 4 carbon. So isobutyl bromide. IPS name will be 1-bromo-2-methyl-propane. When go for other structure, C is the thrice CCH2Pr. So a similar structure I have drawn here. You can find that there is a 2-methyl group in the second carbon. So we can call it neopentyl bromide in common name. When go for IPS name, 1-bromo-2,2-dimethyl-propane. Next structure, we already studied that when the halogen atom directly attached to sp2 hybridized carbon, we can call vinyl group. So here halogen group is chlorine, so vinyl chloride. IPS name will be chloroethane. If you go for another structure, CH double bond CH, CH2Pr, you can give here numbering from left to right, because instead of numbering from halogen, you have to give numbering from double bond. So here common name will be allyl bromide. When we already studied earlier that the halogen atom, if it is attached to sp3 hybridized carbon adjacent to sp2 hybridized carbon, so we can call allyl. So allyl bromide in common name. When go for IPS name, 3-bromopropene. When go for other structure, in haloarene, chlorine atom where it is placed, that carbon will be the number 1. So this will be the second carbon. So common name will be orthochlorotoluene. When go for IPS name, 1-chloro-2-methylbenzene. We can also give other name for 2-chlorotoluene. When go for the another structure, C6H5CH2Cl. This is C6H6. Instead of in place of hydrogen, we have CH2Cl. So we can call this C6H5CH2Cl. Common name will be benzyl chloride. In IPS name will be chlorophenylmethane. Let us see here some of the compound writing IPS names. Then go for first structure, CH3, CH, CH3, CHCl, CH3. Here you can give numbering from right to left. Second carbon we have chlorine group, so we can call 2-chloro-3-methylbutane. When go for this structure, you can find we have chlorine we have in the first carbon, whereas we have double bond structure we have in the second carbon. So we have to give preference for first carbon for halogen atom. So this IPS name will be 1-chloro-3-methylbutene. When go for third structure here, we have 4 carbon. The halogen atom is attached to here this carbon, but we have to give preference for this halogen atom only, because double bond we have only in the second carbon. In case this double bond, if we have here first position, we have to give preference for second carbon, double bond. Okay, so here halogen atom is placed in the first carbon. So this will be considered as a first carbon, this will be second carbon, this will be third carbon, this will be fourth carbon. So this will be named as 1-bromobutene. Another compound, you can find that there is a benzene ring. First bromine group will be here prepared first, because no other functional group here. So the bromine atom is attached here. So this carbon will be the first carbon. So second carbon will be CH3. Fourth carbon we have butyl group, isobutyl group. Isobutyl. So you can write it this IPS name as 1-bromo, 4-secondary butyl, 2-methylbenzene. Let us go for another topic after the nomenclature, nature of CX bond. Halogen atom, fluorine, chlorine, bromine, iodine are more electronegative than carbon, because it is the 17th group. Okay, so therefore carbon halogen bond of alkyl halide is polarized. The carbon atom bears a positive charge, whereas halogen atom bears a partial negative charge. Okay, why it is the halogen, carbon halogen compounds are polarized? Yes, it will be always, it bears partially positive charge and partial negative charge. So it is polarized. The carbon halogen bond length increases when go from C carbon F to carbon iodine. In case of haloarene, the carbon atom attached to halogen is sp2 hybridized. We know earlier that. Okay, you can see here both this is haloarene, this is haloalkane. Here halogen is attached directly to sp2 hybridized, whereas here in haloalkane, halogen is attached to sp3 hybridized. So you can find this is the main difference for haloalkane and haloarene. So here in this lesson haloalkane haloarene we have totally 4 parts. This is the part 1 video. Thank you my dear students.